Hello, my epic pre-calculus class. We are ready for another online adventure. Today, we will verify trigonometric identities. On page 563 in our ebook, there is a review of the trigonometric identities, the Pythagorean identities, the even-odd identities, the reciprocal identities, and the quotient identities. When you look on that page, you'll see something like this, page 563. You have your Pythagorean identities, even odd identities, reciprocal identities, and our quotient identities. We have certain guidelines to help us when we verify a trigonometric identity. And one of the guidelines will be that we work on one side of the equation only. One side of the equation only. We work on one side. And that one side of the equation that we're working on, we want to start with the more complicated side and transform it in a step-by-step fashion until it looks exactly like the other side. Then we would like to look for opportunities to use the identities and make the proper substitutions. Also, we may have opportunities to factor the expression, square a binomial, or add fractions. And also another way to prove that an identity is true is to change everything in terms of sines and cosines. Sometimes that's the easiest thing to do. So the very first thing we're going to do is verify this identity. Tan of theta times cosine of theta is equal to sine of theta. Well, the left side looks like it's more complicated than the right. So we're going to just work with the left-hand side. We're going to substitute for tan of theta, sine of theta over cosine theta. And that is one of our quotient identities. You see right here? Tan of theta is sine of theta over cosine of theta. So I substitute that. And notice that the cosine of theta and the cosines of theta cancel out. So we're left with sine of theta equals sine of theta. So what we've done, we've shown that the left side is equal to the right side. We only work with the left-hand side. So we have verified that this identity is true. Let's look at another example. We're going to verify that the quantity 1 plus sine of x times the quantity 1 plus the sine of a negative x is equal to the cosine squared of x. Well, we're going to apply our even odd identity. The sine of negative x is the same thing as the negative sine of the positive x. And that, you see, is our even odd identity, which is right here. The sine of negative theta is equal to negative sine of theta. So I substitute that. Then I'm going to FOIL, the first, outer, inner, last. So when I FOIL, 1 times 1 is 1. 1 times the negative sine of x is negative sine of x. Sine of x times 1 is sine of x. Sine of x times the negative sine of x is a negative sine squared of x. And you'll notice here we have a negative sine of x and a plus sine of x, which adds up to give us 0. So what we're left with is 1 minus sine squared of x. Now this 1 right here is equal to cosine squared of x plus sine squared of x from our Pythagorean identities. You see, cosine squared of theta plus sine squared of theta is equal to 1. And then we've got that the sine squared of theta minus the sine squared of theta is equal to 0. So we're left with cosine squared of x is equal to cosine squared of x. We have shown that the left side is equal to the right side. We have only worked with one side. And we used our even-odd identity and our Pythagorean identity. Let's review how to factor the difference of squares. If you have a squared minus b squared, you take the square root of the a squared, you get a. Take the square root of the b squared, you get b. And then remember, one has to be positive and one has to be negative. So this is our factorization of the difference of two squares. We're going to use that to help us solve or verify this identity. Here we have our left-hand side, sine squared of theta minus 1 all over tan of theta times sine of theta minus tan of theta equals sine of theta plus 1 over tan of theta. Now the left side again looks more complicated than the right, so we're going to work with the left-hand side. And see, this numerator is the difference of two perfect squares. So sine squared of theta is sine of theta times sine of theta. Square root of 1 is 1, 1. One has to be positive, one has to be negative. Then in the denominator, I'm going to factor out the tan of theta from each of these two terms. So when I factor out the tan of theta, I'm left with, in the parentheses, sine of theta minus 1. And I always go back and check, when you're factoring, check by using your what distributive property. Now, when I did this factorization, notice that the sine of theta minus 1 and the sine of theta minus 1, they factor out. So what I'm left with is sine of theta plus 1 over tan of theta equals sine of theta plus 1 over tan of theta. And we have proved that the left-hand side is equal to the right-hand side, and we have verified the identity. Again, we only work with one side. And as we are going through this video and reviewing this video, always remember to stop, rewind, review. Stop, rewind, review until you understand what is happening. And my love goes out to you.